Hey everyone, today I'm going to go over some R basics. So on the agenda for this video is just showing that R can do math, which is the most basic of the basics, then talk about variables and assigning values, then talking about R as a programming language, which programming language comprised of objects and functions, and then talk about functions a little bit, and then both objects in terms of what class of objects it is, and also the type of objects, in particular vectors and data frames or tables. Then we'll be talking about logic and how to implement logic in R, some sort of simple logical operators, and then putting data together and then subsetting data, which is the main thing that you'll be doing. It's just as you clean up data, as you imagine if you use an Excel document, what you're doing is you're kind of subsetting, you filter things out, and you select certain things. Just to start off with, R can do math, so math is sort of familiar to all of us, and so I think that is a good place to start. So the first thing is, this came up before, but if you were to just type in math, so like 5 plus 1, and you hit Control Enter or Command Enter, you can see the output here in the console, you get 6. So R is able to do math, and it interprets and also evaluates the expression that you put in to the console. So oh, and the other thing about this is I will post the script that I'm writing here if you want to look at it for any particular reason or follow along. However, I would recommend just thinking if you're watching the video, just instead of trying to type out the things that I already have and also the things that are as I type them, I would recommend you watch the video, and this is going to be true for all of the videos I'm coding in R. I more recommend you just watching and trying to figure out what R should spit out, sort of what's going on. Usually when I started learning R and I came across something, a tutorial or some sort, I would try to keep up with the person typing, and then that just meant that I was just typing what they were doing and not really understanding what they were doing. So that is my suggestion to you, but of course do what you think will help you learn best. And so there's the basic things, operators, so you can imagine how you do plus, addition, I did plus and addition at the same time, but subtraction, addition, multiplication, division. You can also do to the power of, with the caret operator, various different math functions. So nothing too interesting about the math. It will just evaluate and sort of give you out a value below. So the other thing that is, again, why it's good to start with math is because of variables and assigning variables in particular. So similar, like again, math, if you want A and you wanted that to be a value, you could just have it be 5. Apparently 5 is my favorite number right now. And you can see what happens is that A is, this value is now interpreted as 5. So if you were to say before doing this, let's just say B, because B doesn't have a value, and you say B plus 5, R is going to be, object B is not found because it wasn't assigned to anything. But now if I say the same thing and put A plus 5, you're going to get out that it's 10, 5 plus 5. So that's nice. There are two ways to assign variables. I was saying it's like math, so you can use an equal sign, but we'll get to why you shouldn't use the equal sign. So don't do this. Mainly it becomes when you talk about functions. You'll use equal signs when you're defining something, a parameter within a function, and you'll use a variable. When you assign a variable, you use the less than sign and then the dash. So if you want, there are almost always shortcuts for every single thing that you would want to insert or do in R, like the Control or Command Enter. To run a line of code, you can also hit Alt and then hit this on Windows at least. Alt and then the dash will make the assignment key appear automatically. So, and it works when you're commenting things out. I suppose I should mention that this, in case didn't watch any of the earlier videos, this pound sign means that it is considered a comment. So that is how you can write text in R. And there's other ways if you're using R Markdown, which will be covered in a different video. But for example, if I just highlight this and run, it doesn't do anything. But if you were to type in something like along the same lines, like variables, assign, you could see like why this would be bad because it will try to interpret it as code and you'll get an error message, might stop your code from running. So yes, so let's say make a comment here to say use the assignment key to assign values. It's not necessary. You will find scripts and code that will have be say equal to, but it's just the sort of customary R nice programming thing. The other thing about nice the programming when you're assigning a value, right now I don't have a particular use for for A, for example, but so that's why I'm just using A, but you want to be descriptive. So let's say it's not just a value, it is like the starting value. Then it's good to be very explicit in what you're naming or assigning your objects to be. The reason for this is just because it'll make your code just much more interpretable. A lot of people will do shorthands, but when you're coding in R, one thing that's nice is, let's say this is 10 times 50, which is pretty obvious. It would be 500. But if you just start typing things out, and then you can see that it tries to give you some things that it thinks that it could be. So you can keep typing it, and if you hit tab, it'll autofill. So maybe that wasn't great because there's a lot of other things that start with start, but you can eventually get to it, and you can use the arrow keys to navigate down to starting value, and you don't have to type in the whole thing every single time. So that is nice. The other thing I will say about assigning values is that you can't use the dash. You can use a period in the name, but if you use the dash, or it thinks of it as the subtraction sign, so it will try to subtract starting from the other thing, and if you don't have that, it won't work. So, and the other thing I wanted to cover about math, actually, and so if I will go back up, that I forgot to say, is that it runs through that math if you have more than one values. So I showed this in the RStudio, but if you do 1:10, you get the values 1 through 10. And you can see that right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to clear the console. That's Command or Control L. And so you can see that this is actually a series of values, a series of integer values. And so what happens if you were to say like 5, of course it has to be 5, 5 times this series? Well, what you'll end up getting is every single value is multiplied by 5. And that's really convenient because basically allows you to do math and do operations and set that up to work once, and it will automatically go through this sort of vector and identify what, like, the result. It'll make the result happen for, the operation happen for every single thing. There are ways where you could make it happen just to 1 or 2, and that would be regarding doing the subsetting, which I'll get to later. So that covers just assigning variables. Like I said, you do want to be explicit, even though I won't be the most explicit usually in this basics thing, because we're just looking to start some values and everything. So the other thing that is nice to compare R to, because it is a programming language, there is a nice comparison between programming languages and natural languages. And if you were going to stretch that analogy further, you could think of nouns in a normal language being objects and verbs being functions. So let's talk about functions first, and because it's also very similar to math. So let's say you wanted you can make a function in R that is more advanced. It's usually that you're using it, but I'm going to use this, show it just to give you an idea that it can be thought of very similar to how you think of sort of functions in math. So let's say I want y, and I'm going to make that a function. And how you make a function in R is there's a function called function. And what is this a function of? So I can say it's a function of x, right? So this is basically going to be an f of x. And what is that function going to equal? We're going to use these these brackets. It doesn't really matter right now, but let's say I'm going to make a function x squared. So y is equal to x squared is basically what this is going to be. So x caret 2. And now if I hit Control Enter, you can see that this function, because I defined it myself, is kind of a special thing that it gets up in this environment panel. But it works exactly how you think it would. So if I wanted this function of y is, let's say 2, I'm of course going to get 4. If I wanted to change this value to 3, then I should get 9, etc. So that's one way to do it. And then of course you can save this value that you get out of the function. So, you know, let's say, you know, the first, like, if it was going to be a point on a number line, and would be, you know, x is 3, y would be 9, for example. And if you wanted to get multiple points, if you could do the same thing that I did before, so let's say, and this time I'm going to, instead of setting just 1 through 10, I'm going to set the variable, I already used a, so let's use z, no, maybe not, m, sure, m. 1 through 10. There's no reason not to use z, I just didn't want to confuse the fact that I'm using math functions and talking about like a third dimension. So m is now these values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's this sort of series instead. And so you can imagine what would happen if I put in m right here. It's going to run through these values and go and square each of them. So if you look at the point, now it's actually, now I don't have just one point, I have this series, which is, you can always print it out to the console as well. If you just all you do is put an object in, it will, RStudio and R's default is to just print the value. So you can see that you get 1, 4, 9, 16, etc. So it clearly did use this function on each of these values independently. And you can see how this is going to be useful when you're manipulating data. You know, if you need to normalize the data, if you need to subtract a value in a data frame, these values from each other, it will do it automatically. So that kind of covers verbs, as in like the things, functions are the things, what you're doing to these objects. To cover objects a little bit in more detail, we already covered like there's these values and there's also a series. Well, the series has a technical name and it's called a vector. So if you want to create a vector in R, you can put anything together, and kind of go over this a little bit later, with this function C. C stands for concatenate. So let's say I wanted to put, you know, just make a vector of 5, and then of course it was 5, 8, and 9. And so all this code does is put them together in this kind of series, 5, 8, and 9. And I suppose I should tell you that this 1 that's printed here tells you, and why it's always a 1 that's printing there, it tells you what basically is it's an index. It's just saying this is the first position of this thing that you had me print out, is starting here. So you can see if you did something like 1 through, typed in some extra things there, 1 through 100, and you type it out, you'll see that, and this might look different for you if you were to type this out based on how big your console is and everything, but it's showing you this index is basically saying this is what this row that's printed out here starts with the value 1, this starts with the value 21, 41, 61, 81, etc. So vectors are important because they're basically just, you know, a series of data. Don't call them a list, because a list is something different, and I can cover that just briefly later. So this actually should go over here in the underneath the vectors. So in terms of the types of things, the object class is the thing I wanted to start with first. But it's fine to talk about vectors and just in numeric sense, because these are both these are the things that we've been functioning already. But there's not just numeric values, right? If you have a table, you can use a table where you'd have text. You can do textual analysis, and like there are ways to look at, for example, works of literature and see if they are more happy or sad based on the words, and the word, like you can say like good, oh that's a happier word, and give it a point score and everything. People do that. I don't know why. I'm not in that field. Just saying that but there are people who do that in R. usually we're going to be using it for numbers, but of course characters come into play as well. So a character is any text, but you can see where there's going to be a problem already. So if I wanted point, you notice that it considers it an object, where you can though put it in a parentheses, or not parentheses, in quote marks, and you can either use single tick marks, and also if you highlight something, this is a really convenient feature of R, and you hit the quote marks, it will automatically put quote marks around for you. And also, if you notice how what happens here is that when I only have one, it puts everything else in green, because it's saying, oh, all of this is now a character, because that's RStudio kind of updates how you are, where it is. And so when you put the second quote mark, it's like, oh, this character starts at the first quote mark and then ends at the second quote mark. So if you ever see that, that's what's going on. So now, if I were to print that, it would also just print point. I mean, the common sort of coding thing is to try to get to send to console like hello world, and you can use print to print things explicitly to the console. That comes in sometimes when you're using functions and things of that nature, or when you're using for loops and things, so don't need to worry about it too much. Or like I said, if you just put hello world, that would also, the default option is to print to the console. So that is both examples of characters. And I already talked about vectors, so going back over here, let's talk about a character vectors with characters in them. And it's the same thing. In this case, you just do C, and then you do A. Let's say you just wanted the letters B and C, and now you have a series where you have the letters of the alphabet. So, and the same way, if I wanted to save any of these values, I could easily save this value to be, text string. A string is a series of characters, so any character is pretty much is a string. You'll see that also when you're hoping to sort things, and it can be useful just to know that sort of terminology. So text string is point. So that's the characters, and this is how you make a character vector. It works very well. And so the next thing to talk about, the other main important one that I wanted to cover on, is just logical values, and that is just to say true. You can see it colors it differently because, again, it's RStudio has a default thing where it nicely colors things that are different. You can see that objects generally are white, character strings are in green, and logical values are in this orange. This is based on my how I set the appearance in the global options. But so you can have true values and false values, and this will become really important when I talk about logic a little bit more. But again, you can say you can set like any value or assign values to be logical as well, and you can also do a series of logicals. So if you want to do I'm going to copy and paste this over here. Let's say values, and again, how you would make a vector of this and how you'd bring things together. Be true, you can say false. The other way you can do it is just with a T or an F. It's less explicit, but it saves you 3 keystrokes. And with RStudio highlighting things, it's a bit better, I think, than if you would. Usually people say you should be as explicit as possible. It's just a better coding practice, so you can clearly see, oh, I see what I'm doing here, or see what this other person is doing here. But and now you have these values, and if you look at what it shows you here, it shows you that you have a logical value of true, false, and so a logical vector. So that gives you sort of numeric and character and these values. I should say that there is a difference between numeric values, which are double precision real numbers, and integer values. And so if you can see the difference here, one of them says this one, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, is integers, but the this one is num for numeric, or the double precision real. It doesn't really matter. That just means that they are allowed to have decimal points and it's not allowed to go out very far. So you don't need to worry about it, about how far it goes. It's very precise. That's the double precision real. If you want to look into it, you can feel free to Google it, of course. If you wanted to make sure that it was specifically an integer, you could put an L afterwards. And for some reason, there's probably a reason for this, but I don't know it. The L indicates that it is a integer value. Object class is very important, but not necessarily for integer or numeric distinctions. It is nice to know that R can consider these differences as important, and that's sort of a general thing of knowing whether or not the differences are important, and whether or not the programming language that you use actually is smart enough to handle them in reasonable ways. So we talked about characters, and we talked about logical class. If you're ever wondering what the class of an object is, you can do class, and that's a function. So I'll put that up in the script so that it gets saved, but class, and if I put class of W, it says it's an integer, whereas if I put class, let's put a new thing, of test, it's numeric. Again, that sometimes it'll be important when things get changed. There are certain instances as well where when you read data into like in a data table and everything, typically a data table has to have the same, a column will have to have the same class. So either it's an integer column, character column, or logical. And usually it defaults to be numeric if not integer, but that is a consideration. And so sometimes the default will be that it will be a characters if it can't guess, if it can't just be, it's not just numeric, it'll be characters. And I think I can show that off right here. They're saying let's talk about vectors so that we can have a series of things. So we talked about a vector of a numeric vector, again, numeric, technically an integer vector. That's great. This is a character vector, and then the logical vector. There's one more thing, though. Of course, you can try to put them together, and if you were to say, let's say combined vector, ooh, I know how to spell. Let's put C, and let's put 1 through 3 together, and if you would type ABC right here, that will just that's one value that is ABC. So now the vector would be length 4 with 1, 2, 3, and then the fourth value would be ABC. And then let's put D and E. And you can put true in quotes, and that's actually the word true and not the logical value. So if I put a combined vector, and let's combined vector, you can see that it came up in the environment, but let's do class, and actually you can kind of get what it's going to be. But let's make it explicit and do combined vector, it is character. The reason for this is because it doesn't know what to do. When it needs to have a class, it needs to have one class in particular because it's one object. So it really can't have multiple classes together. And so you're going to convert the 1 to the value, to the string, the symbol that is representative of 1. So now all of a sudden, even if I wanted to take the first object of this combined vector and do this function, y, it won't work. So If I were to take y and do the combined vector, and let's say I just want the first value, and I'll talk about this more later, but that gives you a taste of how you subset things. This is asking for the first value of the combined vector, and that's how, same sort of notation you see down here that I mentioned before. And it says it's a non-numeric argument. Even though originally it was a 1, it got converted to a character. And that's where you need to be particularly concerned about these different classes of things. So, error. All right. So there are ways to convert things back to characters and things like that, and I think that'll be for a different video. There's a parsing function that you can use, though, if you're interested to look it up now. Data frames and tables. So right now you can see that we have a function and we have these values, but you can also have tables, which is the thing that you're going to mainly be using in R. There's other things as well. There's matrices, there are arrays, and there's lists, but it's not that important. Usually, if you're just beginning, really you just want to worry about tables and data frames. So if you want to make a data frame, all you need to do is put data frame. It's a function, and what you do is the first thing that you set for it, it says like ... The first thing is it just assumes that whatever you're putting in is a column. So if I put 1 through 3 here, and 4 through 6, basically it'll say 1 through 3 is the first column, 4 through 6 the second column, and maybe I want to have, the second column be this. And I think the reason I wanted to do this is that I wanted to point out that when you have a data frame, you can see that it kind of just prints off the data frame because it doesn't really know what else to do with it. You can store that. I should store that data frame example. You'll most likely see a data frame be stored as like often if people will just be using it just as an example, they'll use df. That is sort of a shorthand where you can expect it to be a data frame. So now you can see that there's a data sort of header here, and if you click here you can view it. You also can view it by just typing view. There's a function and putting this into it, and it puts it up here, and you can see that we have a column where the column 1 is named x 1.3, this one's x 4.6, and then this is this vector c a b c. Not really nice names. We can set that in a different way, but this is actually okay. It is okay to have a before, remember when we had a vector, we couldn't put numeric objects with character objects, but here we can put character numerics, and this retains, like, these values are numeric values and these are character values. But the only thing is that when you look at you can't have for every single column has its own sort of class, and this is something you'll see when we talk about sort of subsetting data and everything. But really all you can think of, the sort of relationship between vectors and data frames is that columns are vectors and rows are vectors as well, but usually you think of things as grouped as columns. So if I wanted to say class data frame example and run that, it's just going to say that it's a data frame. So it's like its own separate thing. It can have this mixture of things all together. So what you would expect from a table, what you could have in Excel, like if these were named things. So now the other thing, like, to get into subsetting data and putting data together, we kind of have to talk about logic and how you communicate. So it breaks down a little bit in terms of that, like, natural language and also the sort of math thing here, in that you need to communicate with R in particular logical ways. And so usually how you're doing when you get logical values, usually you ask a question. So if you were to say, let's take the value m again. So if we print off m, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can ask the question, again, mathematical question, what is m less than 5? And it's going to put out a series of true, false statements. And you're able to kind of, in a way, convert this numeric vector into a logical vector where it's true, 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 and then false all the way through, as you would expect. So there are important sort of logical questions you can ask. You can ask less than that, less than, greater than or equal. Some of the most important questions, though, are is equal to or is in. So let's say I wanted to know, let's say I didn't know in terms of like m, for example, are any of the values in m equal to 3, for example? And so how you would do that is you would say, equal sign would set it to. So if you ever type this in, and this is again why you don't want to use the equal sign, that would set, if you did this, it would be, you'd rewrite the m to be, just do it, you rewrite m to be 3, and so it is equal to 3. That's not really a question. So let's reassign m to be 1 through 10, and the question, how you ask the question is equal to is equals 3. So equal sign, I guess. But you would read that in terms of how you interpret that in sort of a meaningful ways, is equal to. And it's going to go through the same thing. It's going to check the first value, 1, is that equal to 3? No. And of course you get this 1 true value here, and the rest are false. And then the other way to do this is, let's say you wanted to know, are the values 3 and 7 in this in M? So how you would ask that is, you'd have to get a vector of 3 and 7, but you can't just say is equal to M, because if you ask that, it's just going to look at the first value. Here you can see that it's just true here. It's a sort of weird way of R tries to interpret it, because it can't really print off both of the results, asking is 3 equal to any of these values, and then is 7 equal to. And usually you get a warning message that says you can only use the first value. But is equal doesn't really work. And also it's not, you can see that this is not equal. And if you were to ask it in a different way, right, this is a vector where it does only 2 values, and this is a vector that has 10, it starts getting confusing. But what you want to do is percent in percent. And this is also a logical question that is asking, is it in M? And so if you hit enter on that, you'd say 3, yes, is true, that it's in M, and 7 is in M as well. The sort of syntax for this, you can also ask it the other way around. So you can say, M, what values of M are in this vector, 3, 7? And now you can actually go through the series of M, and you'll see the normal sort of, the thing that we kind of showed in this line where it was is equal to, but it will ask actually how you would expect in asking for both of them. So now it pulls a false, false, true, false, 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 true, false, false, false. So putting data together, that was kind of what we showed already. There's other ways to manipulate data frames, but that is a little bit more complicated, definitely its own video. But the main thing that I wanted for you to know is that you can always do C. And then not only that, you can put values like, we already have assigned A. So right, if we print off A, you see that it's 5, and M is 1 through 10. So if you want, you can put those values together, and you get a vector where it's now A is at the beginning, and then it goes to 1 through 10. You could put all the values that we wanted, that we, put, I just realized it's called starting value, so let's put starting value here, and then A, and then M, and then test, and all of a sudden we get a vector that is, combining all of the things together. But then to talk about subsetting data. So subsetting data, you saw it a little bit. Usually you want to use the just brackets. So, and there's different ways to subset data. So the first one is subset based on position. So this is how I showed it before. So let's say you had a let's just use M again, and I want the 6th value out. And you see the 6th value is 6, maybe that's a bad example. Instead, I will rewrite, let's say, U, for example. I'm saying it's a bad example because both the 6th value, the 6th place of the series is 6. So it's hard to tell the distinction. So let's actually just write, 20 to 10. And you can do it this way in terms of going down. And now if I were to ask what is the 6th position in U, you see it prints out 15. So that's really nice and convenient if you know what positions that you're looking for already. But you also sometimes want to subset based on logic that is a question. So maybe you only want the values that are less than 15. So if you wanted to do that, you could just do, let's put it in a new line and sort of scroll down a little bit. So U is less than 15 is that logical question. And what you can do then is if a vector is the same length as the one you put in, if it's a logical one, it will try to identify what values. It will sort of do a one-to-one analysis. So let's just do it and see what happens. So if you put U and then the brackets and put this in brackets, the idea is that it's going to ask that question first. With coding, you almost always read inside out. There's certain ways to do it, but not with subsetting. And we'll talk about pipes and how you can make it so it doesn't read inside out. But it's going to ask this question first: what values are less than 15? And then, as you might imagine with a logical question, a nice thing that it does is only takes the true values. So maybe there'd be a better example first. Get maybe a different example to begin with. Let's say just like P is let's just say 1 to 3, so I don't have to type it out 10 times. P is 1 to 3, and then if I want to subset, again, I need to have a logical vector. So I'm going to use C to put these things together: true, false, true. And just based on that, you can maybe think, based on how I was kind of setting it up before, that you only get the true values out and you leave behind the false values. So you're skipping 2 and you just get 1 and 3. So in this case, you're going to get this question of U is equal to, or U is less than 15, and it asks where is that true and where is that false, and then it's going to just pick out the ones where it is true. And so if you do that, you get 14, 13, 12, 10, 11, 10. So going on down. The last way, and so it can be really useful to do this. So let's say sort of is equal to. So let's say I had two vectors and they were just different. Remember, point is this vector that is 1, 4, 9, 16 as it goes on. And I wanted to ask that in question. So what if I wanted the values of M that are in point? Well, that's how you get the logical thing, and it shows true, false, false, true, false, going through. And so it's only, and so if I wanted to subset this, I would put in those brackets. And you notice that also with RStudio that a little bit confused because it shows that it's the end of the document, even though there's nothing basically to subset. So we'll try to give you little hints and everything if you do write some code that isn't great. So what that did was it asked where are the values of m in point. So let's take the values of m that are in point by just putting that in front, and all of a sudden you just get 149, and these are the powers of 2. So, it's a nice way to ask that sort of question. If obviously it's a very mathematical example, but it is a nice, it gets at what is so sort of powerful and so useful with these things. If you can ask the right sort of questions, you can get out the data and get it out very quick. And you can also subset it. You can set this equal to something. So let's say it's a new vector, and then is assigned to be that values, and now you have just those first 3 powers of 9. So you can sort of filter and subset based on those logical questions. So doing this in a data frame, I misspelled vector terribly. Let's ignore that. Let's actually, so there are a couple of there's a couple of data frames that are already stored in R, and that is kind of useful to just pulling up. So let's look at the empty cars, and you can see that it kind of already did that. So I'm just going to assign empty cars to be empty cars, just so it's a little bit more explicit that this thing exists. And we can view it, and you see that basically it's just about some cars, Mazdas, Hornet, apparently, I don't even know what that is. Different cars, their miles per gallon, so the number of cylinders their engine is, etc. And so based on position in the data frame, and let's actually assign this to be something. Let's put it as a test or temp. You notice that it actually becomes, you're subsetting a data frame, you actually get a data frame back if you just are selecting on rows. So there are ways to get, and this is what I was getting at regarding vectors. A data frame is actually just vectors that are sort of tied together in columns. Because if you actually subset based on, let's do this and say test, let's say temp, like just as a temporary file, and put the second position. So the second column is this cylinder column, and you'll see that if you do that though, the temp value is actually a value. It's a numeric value. You can't really view it, and it's these numbers one after another. So that's why there's a little bit of difference between like sort of rows, which are always considered data frames, and columns, which you can actually think of as sort of vectors that are just kind of grouped together, because they are, again, with columns, so long as it's the same class of value, it'll work. And if it can't be the same class of values, let's say you accidentally type in a value that is not numeric, and you wanted to add it to a column, and it would just become a it would probably work. It just would become a character vector that'd be added then, instead of a numeric vector that'd be added to the column. So the other way to get columns, though, which is a little bit better potentially, if you want to do it based on names, because again, with a data frame, it actually has these nice names here. And so if I wanted to get, let's say, horsepower out of here, and I wanted to do something with horsepower, analyze it in some other way, or just find the mean of it, you can do empty cars and type it out. And then if you use the $, you can see what it shows you. It shows you all the column names that you could potentially use. I said I was going to use horsepower, and all of a sudden I get a vector again. In this case, it happens to be numeric, where it shows you the values here. And so let's say you had your own table. You can easily find like the mean, for example, by doing this, and it'll calculate it. you read it inside out. You're taking the horsepower from this empty cars data set, and then you calculate the mean value of that. So the other way, and you can also ask those logical questions in here as well. So let's say empty cars, put in brackets, and put, let's say I want only the miles per gallon where it's less than 20. Let's say I'm using, or greater than 20. Let's say I'm buying a new car and I want it to be fuel efficient, and those are the great total I have of whatever 32 cars that I have to choose from. So if I take this, the first thing I'm going to do is say empty cars because I want to that's what I'm subsetting, and then how I'm going to subset it fills in the brackets here. And I'm actually subsetting based on the rows. If you notice, I'm looking for any row that has an MPG higher than 20. So how do I know what the empty MPG is though? So in this case, you can use empty cars again and pull out the M miles per gallon column, and I can ask that question: when is that greater than 20? So let's do this a little bit stepwise. So let's take this first part actually and put it down here, or put it up here, I suppose, so it makes a little bit more sense. You do that, you'll get a logical vector of just trues and false. If I put it in this empty cars, it'll ask which rows or columns I want to keep. Now, right now it doesn't, or like it's unclear, and you should get an error if you run this. Yep, because undefined columns are selected. It's not really clear. Are you trying to do this operation, ask this logical question to the columns or to the rows? And of course, rows are the first thing in the brackets. So now I'm asking which rows exist in this data frame where the empty cars MPG is greater than 20. And I want it to say, let's say I want all of the columns, then if I just run that, I will get a data frame out and it'll print the whole thing where you just get those ones that have higher than 20 miles per gallon. Let's say this was too big of a data frame and I didn't really care about this other stuff that was at the end. You can subset as well by either selecting the positions. Again, you can kind of mix and match. So you can have a logical operation here and then say comma and say I want the first 1 through, let's say, 5 columns, and you'll get just the first 1 through 5. Now this is, gets complicated, and if you were just looking at this, you could imagine it being more and more complicated. You could ask a logical question of the columns and also of the rows. So what I'd probably recommend then is you can always rewrite the an assigned character. So you could say, cars, maybe the cars I'm buying, and the first thing you could do is, let's say I want a subset based on what cars are less than 20, and then all of a sudden I have a new data frame, which again greater than 20 miles per gallon. And then it's like, well, I'm not interested in these variables, so I showed you how you can select based on position, but you could also say minus, and, let's say I wasn't interested in columns. Again, position is not great because you need to necessarily then count. So this is 1, 2, 3, 4, 5, 6, 7. Let's say I'm not interested in 7 through 9 or whatever. Again, I can do colon, because it's going to be integer values here, or I could have typed out 7, 8, 9, but now if I look at cars, it's without these. But what I meant to do actually is take this and sort of rewrite it. So cars is going to be empty cars right away, and now I have the ones that are less than 20 miles per gallon, so I don't need this anymore, and I want all those rows here, and just so I leave it empty, but I'm not interested in those columns anymore, so I use a minus and I get rid of those columns. And this is back to the same data frame that we were looking at before. So you can either combine things or you can do it separately. It doesn't really matter. The only thing that I would recommend sometimes is that it is a little bit precarious if you rewrite your original data, because then you have to read it back in or do something with it. And usually the reading back in is the slowest thing. So you do want to be careful about that. But that is sort of the basics of how you're going to be asking questions in R. Either looking for what values are in another value or equal to another value. And then there's a little bit more that you can do. You can like reorder columns and things like that, but we'll get into a lot of that stuff a little bit later. So hopefully you found this interesting or helpful, and I will see you in the next tutorial.